to factor these types where we have the leading coefficient 5, this is what I'm going to do. I'm going to basically use that product of 10 because I know that 5x squared and 2, I know that this diagonal product of 10x squared must show up in the other diagonal, which adds up to 7x. So I'm looking for how to split up the 7x so that when I multiply them together, I get 10x squared. And that has to be 5 and 2. Well, once I figured that out, I can see that my common factor horizontally is going to be 5x here. My common factor horizontally here has to be 2. So I get 5x plus 2. Okay, so 5x plus 2 is one factor. Okay, and then vertically, we can just divide to get the vertical, but I can also just take the common factor vertically. Okay, the common factor is just going to be 1 and 1. It's going to be 1x plus 1. I can test this by multiplying this out, and sure enough, I'm going to get 5x squared plus 7x plus 2. So some of you who use this strategy of timesing the first times last, this is what's happening here, and it's this diagonal product being equal to the other diagonal product. That's the property that we're using to split up the middle. So here we can do the same thing. I've got 6x squared, negative 6. I know my diagonal product is going to be negative 36x squared. That allows me to split up the 5. Okay, so how do I add up to negative 5? So I have a positive and negative that add up to 5, where the difference is 5, and multiplies to 36. Okay, two numbers that multiply to 36 are 3 and 12. Well, that doesn't work. Okay, 6 and 6 don't work. 4 and 9, yeah, that one works. And it has to be negative 9. It's got to be positive 4, okay, because I need the negative 5x. And I can see my common factor horizontally here is going to be 3 and 2. Vertically, it's got to be 2. And, we can divide negative 9x divided by 3x is going to give me negative 3. Negative 6 divided by 2 gives me negative 3. We can see that our factors are showing up as common factors vertically and horizontally. Okay, so then those are going to be my length and width. I end up with 2x minus 3 and 3x plus 2. So 12x squared here. Oh, just a reminder, you should really always check for greatest common factor first. So here the greatest common factor, there is none, so I'm going to start factoring. Okay, so this is 12x squared. This is negative 5. I know my diagonal product is going to be negative 60x squared. I know it has to have a difference of 17x. Well, 20 times 3 is going to give me the 17, the positive 17 difference, and the product of negative 60. My common factor here is going to be 4x. Okay, this is going to be negative 1. Here the common factor is 5. Here the common factor is 3x. Okay, so then I end up with 3x plus 5, 4x minus 1. And this involves very little guessing and testing. Okay, and some of these, for example, this one here with the 6's, those are, if you were to guess that, there's a lot of guessing and testing involved to guess that one. Okay, so we want to be able to show length and width here, so we can factor first. Okay, I know this is going to be plus 3 plus 4. Okay, or I can go the other way around. I can start with the area and come up with my length and width. Okay, x squared plus 12. I know it's got to multiply to 12, add to 7. That's 4x and 3x. Okay, so I end up with plus 3 and x plus 4 along here. Again, with these leading coefficients, you can guess and test this, but what would be useful is using that diagonal product. So 2x squared minus 7, this is going to be negative 14x squared, and I need to add to negative 5, or have a difference of 5, and multiply to 14. That's going to be negative 7 and positive 2. My common factor here is negative 7 and 2x. This is going to be 1x and 1. Okay, and again, we can double check this by multiplying this through. But however way you do it, okay, we are really interested in just getting the right factoring. Okay, you can do it. I don't mind if you use some different method. Okay, but whatever method you use, you have to be good at it, and you have to be able to do all sorts of different complicated ones, especially these leading coefficient ones. Whatever strategy you use, get good at it, because you have to be able to factor and factor accurately, correctly, and quickly. So this last one here, okay, I've got 12x squared, negative 6. I've got negative 72x squared. I know that those two factors add up to positive x. Well, the factors that are closest together are 8 and 9. So I'm going to use positive 9, negative 8. Now, it doesn't matter which way I put it, to be quite honest. I can do it either way. I can do it 9x at negative 8. It'll still work. What just happens is I switch my horizontal to my vertical, and my vertical to my horizontal factors. So here I factor out my common factor of 3x. Here the common factor is going to be negative 2. Horizontally I get 4x, and horizontally I get positive 3. Okay, and just you can double check this, make sure it all works out. Yeah, all those areas work out. I've got the right factor. So I end up with 3x minus 2 and 4x plus 3. Okay, so that's how we factor. There's lots of different ways it can be done. I've showed you just a couple ways. However, what's important is that you do this correctly, accurately every time, and you do it efficiently, because you're not going to have all day to do this. Okay? You're not going to be marked on your factoring. You're going to be marked on doing some work with factors. So you have to be able to factor, and you have to be able to factor efficiently and accurately.